thanks everyone for coming. We've at Availity, we've made a number of investments over the last year to 18 months on our developer tools, and we thought this would be a great place to showcase them a little bit and get your feedback. And I'll admit there's a little bit of bait and switch here. My name's on the agenda, but Rob McGinnis here and Rob Warner are going to do most of the presenting today. Both of these guys are part of the team, the masterminds behind our toolkit. So I guess without further ado, I will hand it over to Rob. Rob.
Gracias. I guess you introduce yourself later.
Okay.
All right. My name is Rob McGinnis. I'm a developer at Availity. We're going to discuss some of the tools that we built over time, primarily around Node.js and JavaScript applications. And then Rob Warner here is going to go into another world and I presented a little CLI tool. But a little history of how this all started. Like 3 years ago, we were kind of experimenting, moving away from server-side apps into fully JavaScript applications, kind of like the world was doing. And so we wanted to come up with a project that took us away from server-side development and kind of split us out into our own little world. So we wanted to create a workflow that allowed us to do that kind of efficiently. And it was based on some old technologies now. Grunt, if you're not familiar with it, is kind of a task runner in JavaScript. Require.js is a script loader. Backbone is like an old MVC. It's still used today, but it's an MVC framework for the web. And we were leveraging Bootstrap 2 for our CSS styles. Eventually, the project migrated over or kind of merged in when Angular became popular. And it worked out pretty well. This is the project structure, and it was kind of like the kitchen sink of projects. We kind of were really excited working with Node, so we wanted to create everything with Node.js, including the build system, email generation, PDFs, you name it. It was kind of fun to work in this space. And the project was designed to only really deploy one web app. And it became kind of popular within the organization, and we added even more projects to it. You can see a projects folder at the very bottom. So we added more and more, and it worked out really well for a very long time. There were some downsides to it, though. As the project grew, the build times would exceed because we were putting everything in one project. When there was like a build error, it became a problem because it would shut down the build process for all the projects. So we were hoping to get away from that in the future, but it was kind of working nice, and we kept it for quite a while. We also had a mock server built into this project, a CLI tool for scaffolding. I mean, it just had everything. And we got to the point where we needed, I'm speaking in this right, where we needed to potentially split this out because we wanted to go a little more modular. And there was a point in time a couple months back where, actually a little longer than that, where we wanted to introduce third-party developers into the system, and there was no way we could hand them this project. It was kind of a developer internal-only tool. Another problem we had that we wanted to solve is not everyone wanted to build JavaScript apps. Sometimes they just wanted to reuse the styles, and this old project had our foundational code in it. Actually, there was a project in there called Foundation that contained our common styles for all our organization. And it also contained some common code, not only in JavaScript, but in CSS. And there were some teams across the entire company that just were, maybe they're working on some appliance and they just wanted to apply some style to their site. And there was no way we can share it unless it was already deployed to a server and through a URL. And they just wanted to consume maybe just the styles or one of our libraries, and it was just not possible because everything was bundled together in one project. So we went down the idea of separating everything out into reusable modules. And so one of the first things we wanted to solve was the style kind of sharing. So we created a project called Availity UI Kit. Now this is a Bootstrap theme, basically, with an Availity twist to it. And this is what we now share across the organization. It's based on Bootstrap 3, Gulp. So that was one of the big twists that we did. We went away from Grunt and went into Gulp. purely because it was new and it was the hot new kid on the block, and we were going to open source it, and we just wanted to look a little cooler than Grunt. And then Metalsmith is our static site generator. One of the goals of this project is to create a living, breathing style guide so that you just download it, make some changes to the CSS, and you kind of see the results right away. Browser sync was used by the developers to keep their styles updated on their browser so you don't have to hit refresh all the time. So these are probably the main tools in the stack. Let me just show you real quick. I'm going to drop into So if you're a developer, you download the project from GitHub. So all our code is open source, which is a kind of a new twist. At Availity, we're trying to get into the open source space. Just to show that we're involved and you can use this code in your projects. And so you type in Gulp, which is, so let me type in Gulp up here. And all our Gulp is, we're using it as task runner. And what you see here is a list of tasks being run. And each one of those is like a little JavaScript function that's running and doing something. We tie the default task of Gulp to all these things that you see on screen here that are printing out. And in essence, it's kind of doing stuff like copying images and minifying files or whatever. And it puts you in developer mode. Oops. Oh. Where'd my Chrome go? Sorry. You know where the Chrome went?
You have to relaunch it.
What? Sorry. Hold on. Let me get back to where I was at. Okay, sorry about that. All right. So it puts you straight into development mode. Now I got to go back to my. Oh. Unexpected turn of events. All right. Okay. There we go. Back to normal. So we were using Gulp, Metalsmith, and some other technologies. And one thing we wanted to do was be able to refactor as needed. And we created a config file that allowed us to share some common, targets and sources and destinations across all our plugins and functions that we were using. So this config file is tossed around to all our NPM modules to configure our project. Here's an example of the way we break up our Gulp tasks. They're broken up by feature. Yeah. And then it keeps it nice and neat. Before we were putting everything in one big Gulp file. So it made the organization wasn't that great. So now we have a little bootstrap file that looks into this folder and loads everything up in Gulp. And so if you want to create a copy task, it's in the copy.js file. And then we pass the config file on line 7 that we showed on the previous screen to Gulp, and it knows where to pick up the source files. It runs it through. This is a simple task. We're just copying to another folder, but the other ones kind of mutate the files as you pipe it through Gulp. So it's really nice and neat. You don't need to use Gulp to do all this stuff. There's, Grunt is just as good, but Gulp was the new kid on the block, and that's why we used it. So another technology that we wanted to use, you can kind of see that this is our UI kit. You can kind of play around with it. It's, the idea is that you should be able to, as a developer, come in here and see, if someone's telling you, hey, you need to build a mega menu, you just come in here and this is the example that you have. The source code is available, right? If you decide to click on it. So it's supposed to be copy and paste. And this really helps speed up some development processes because you don't have to think about how to style your stuff. And it's a little twist, and since it's Bootstrap, you're kind of familiar with it if it's one of the most popular frameworks out there. You can see that we're on 10.1. This is the dev branch. But so we've had a couple of iterations already on this style guide. Kind of examples of our charts that we've established to be the standard across the whole company. So you just come in here, copy and paste code, and you're off to the races. We also wanted to establish, not just components, but how they all are composed together. So this is actually what our navigation bar looks like up top, and down below is what an app would look like. And we're going to get to how you build your app in a future slide. So all that stuff was built by Metalsmith, and it's really, really simple. Same idea. You hand it a set of files, you run it through some functions, it transforms the data, and you get an output. Same concept as Gulp. Very easy, small footprint, like API footprint, and also it was easy to extend it. But the two worlds didn't mix well together. By default, Gulp has some file system that it uses in memory for streaming. Metalsmith expects files, so we're kind of branching the two here. And we use Gulpsmith for that, but in essence, you're just, again, at line 75, you're grabbing a set of files, running up through some functions, and each step here, each pretty much line item is a different transformation that's happening on these files. And that's how we build our style guide. We use handlebar templates down below. There's many templating libraries on the internet. There's probably thousands. We just told handlebars because that's the one we are accustomed to at Availity. This is an example of a Metalsmith template. Up top is, they call that YAML front matter, and it gives you instructions. It tells Metalsmith, hey, for this page, I want you to use the title inbox. I want you to use the template example page layout.hbs, and the collection kind of puts it in the right place so I can iterate through it with a static site generator. Because we publish this out to GitHub pages, and there's no server backing it. So it kind of does all this work for us. And it was so cool, in fact, that we decided to open source even more stuff around Metalsmith. Two of them being, these are the two up here. The one's called Metalsmith Prism. It's actually available on the Metalsmith IO site, on Bower and everywhere, or actually on NPM as well. And Metalsmith Mock. And basically, it's just a syntax highlighter for your static generation. And we were using that on a bunch of our, it was all about documentation when you're building a platform. Without docs, you probably have nothing. So it was all about documenting, and we do a lot of code, so the syntax highlight is important. So this is a plugin for Prism.js, that uses Prism.js for Metalsmith that outputs this every time you highlight your HTML with, or actually use the code snippet in HTML. Here's a snippet for how you would use Metalsmith Mock. And what I was finding is that I was creating a lot of fake data, like lorem ipsum kind of stuff. But I wanted a little more than that. So I wanted to be able to create a real name or a real address. Because when you're demoing this stuff out and you kind of have fake data, people lose, I guess, their ability to understand what you're trying to present if it's full of non-real information. So what Metalsmith Mock does is you just pepper your DOM with the data mock attributes, and you tell it what you want it to fake out. And the :1 that you see up there is the profile that you want to use. So it looks up in a registry, and if there's no profile one, it creates one with all this fake information. And if you use that same profile throughout the site that you're generating, it'll use the same names, addresses, you name it. And here's an example. Oh, is it kind of blurry? Here's an example of what that can do, and actually I can show the live site. Okay, cool. So we're using the Metalsmith Mock to generate all this fake data, so it looks like real without me having to go in there and do it by hand, which is always a pain. Drop down to the CLI. So we were building open source, and we've never done versioning before, which is kind of strange. We kind of just push up code before this project, and it just got part of a release package, and it just went to prod. So now it's a little different game. You have to worry about not breaking your customers that are using this. So we wanted to ensure that versioning was, let me just run a little CLI here. Established using Semper. So we create a little task that lets us release our code, and kind of, you kind of do commits, git commits, and you're fixing stuff, bug fixes, updating the documentation. Run a little CLI tool, and it asks you what version do you want. So if it's a patch, it means like a bug fix. If it's a minor one, we're probably adding some features, and a major one is breaking. Semper is kind of weird. Anything below 1.0, you can break your customer, and we're not at 1.0 yet, and we're going to be shortly. But if you just give an answer, it runs a series of Gulp tasks that not only optimize stuff for production, you can ignore that, that's just a warning. I'm not supposed to, we're using an old library to generate a README, and that's what's causing it. But in essence, it's running all these utilities, and it creates a distribution for production and for GitHub, so we can publish it on Bower, and the whole world can consume it. And it also tags it in Git. So if I do, let's see, git log, the red is the different tags that we're using, and those are all the commits that we've done in between releases. Since my old browser closed, I was going to show you the GitHub page where we actually document the changes. So we comb through these commits, document the changes on GitHub, and we release it. So if we make any breaking changes, our customers would know. We're hoping to automate that. Right now it's very manual, and we'll get there one day. Do we have any questions about Gulp or the UI kit or anything like that before I move on? No? So another library so we kind of solved the shareable styles across the organization. Now you don't have to be in that project to use it. We also wanted to share a common SDK across the company. So we created the Availity Angular library, which is nothing more than a wrapper around some of our services that we have on the server side, particularly around our REST API and some other functionality that you get if you jump on the Availity platform. So the Angular project is based off, it depends on the Availity UI kit. It also uses Gulp and Metalsmith. So it's kind of a familiar project for those that are developing a UI kit in that workflow. So we kept it consistent there. So we won't go over those again, but what we did establish pretty early on is that if we're creating an SDK, we have to make sure we don't break our customers. But CSS is a little harder to understand when you're not visually breaking someone, but with Jasmine and JavaScript code, you definitely at least have a good understanding that whether you're going to break someone or not if you have a good test suite. So again, we leverage Gulp, and there's different, we leverage Gulp, Karma, and Jasmine. And what Karma does is a test runner for JavaScript, and we wrapped it in a Gulp task. And because we're open source, we have a task for continuous integration on the local developer workspace. We also have one that kind of runs when you're coding, and it gives you live updates as you break tests. And then we also have a task runner for Sauce Labs, which runs every time you make a git commit on GitHub and you push up code. Nope. As a developer, you come in here and you download this SDK. So it has the same style of startup. You use Gulp to start it up because the default task runs all these tasks here. And then it puts you straight into developer mode where you can make changes right away. This is kind of a docs that's supposed to, there should be a lot more docs in here, but mostly my fault that it's not updated. But it's supposed to show you how to get started with the platform in terms of the SDK. This is an example of the analytics that's built in. So if you're building a web app on the Availity platform, you want to know if your users are using it. We kind of wrap it in some JavaScript code, and it fires off some stuff as behaviors happen on the page. So this is supposed to document how that works. And we use open source tools to do some of that too. A lot of the documentation is actually backed by unit tests, and that's where we guide our internal developers and sometimes our third-party developers to go to, because these are not all the way there yet. But mostly what the Angular developers come and try to see is what UI widgets we have in there. And most of these are wrapping jQuery widgets, which is like the thing not to do in Angular, but they seem to work better, especially when at the time of releasing this, we were supporting IE8, and we're sunsetting it now to IE9, so we'll be able to update this library. And the consumers of it will get the upgrade, and we'll probably break them, but we'll version bump and all that. So it's kind of the same idea as UI Kit. You just get into full developer mode, so it's a familiar tool, and you can start making changes, running the tests. Probably the hardest thing to develop was the validation framework. The developing validation in Angular is actually quite easy, but your boilerplate and your HTML becomes just gnarly. So we decided to simplify that, especially for, we were onboarding a lot of developers that weren't strong in JavaScript. They were coming from a server-side kind of life. So to throw them in the craziness of the web is fun to see sometimes. And but we want to guide them to it. So simple JSON configuration file controls all your validation. We actually cherry-picked some ideas from the web. There's tons of validation frameworks out there in Angular, in jQuery, you name it. So we kind of cherry-picked the best ideas and made it our own. And gave credit to him, of course, on our README on the GitHub site. So example of our test running. So we're not going to run that forever because it's annoying, but we do test a lot, and we noticed that when JavaScript or the server-side developers jump onto JavaScript, that it became so much easier to test sometimes, or at least it feels that way in JavaScript. So we do a lot of testing, and it runs every time you check in code. It's really nice. You get that instant feedback that you've broken something. So we solved the shareable styles across the organization and the world, basically. We have a common SDK that we're all sharing, and now we still haven't got to the point where we've replaced the world we were trying to leave, which is like a starter kit to build web apps. There was one more thing we had to do, is rip out the mock server. So Availity is an API company, so everything's backed by RESTful services. So in order to create a web app, you're going to need some JSON coming from our REST services. But as a JavaScript developer, I don't want to load up a whole system to return just some mock data. I just want to code and build my web apps without having to worry about that kind of stuff. As a matter of fact, Rob Warner over here does all the server-side development. I do a lot of the client-side development because I love JavaScript a little more. But if we mock our data identical, like once we agree to the JSON contract, he can go off and do his thing, I can go off and do mine. When we meet in the middle, nobody breaks because we have that JSON contract, and as long as it doesn't change in between, we're good to go. So we created this Echo server. It used to be called just the mock server, and I called it Echo. I don't know why, but it seemed like a cool name. So it's just a Express server in Node that you can download from NPM and use it. You don't have to, it's designed to simulate Aries REST services, Availity REST services. Aries is our product. But you can use it in your own project. And you just pass it a configuration file, and it serves up fake data. And the way it does it is very simple. The configuration file you define a route and a file, and it returns, right? And I was like, great, this is going to work for everyone forever. And then, developers started saying, well, I kind of want to return something different depending on the REST method I'm passing in. And there's many fake JSON mock servers everywhere in every language. This is ours. Everyone has a different configuration, but this is what we use today. So cool. So we extended it so you can return different files depending on what you're trying to do. And that still wasn't good enough. So then we extended it one more time. So let's say this is a v1 route. You're typing in your URL v1 route, and it's supposed to match on the server. And the GET request can actually be kind of complex. You can pass in parameters, and those parameters have to match. And you have to support, you have two examples here. One supports just, let me highlight it here. So if you're hitting that URL and you're passing in params A, B, and C with those values, it should match this file and return with example2.json. And of course, same thing with parameters that are repeated in an array. One of the goals, though, was to fuzzy match, because we do a lot of demos, and we actually have a demo site where we publish all our apps, or most of our apps, and that allows us to do usability testing. So if you're filling out a long form, and it's actually the demo site is powered by this mock server, type in a long form, the developer shouldn't have to put in all the parameters, all the combinations in here, just maybe one or two for it to match that file and return something. So it's forgiving, and at the same time very flexible, so you can get these deep interactions that you want to develop in. Posts, a little tricky because you can submit binary data and also a big JSON payload, right? So it can be a big object graph. So we updated the configuration file to allow different scenarios. So you can pass in a simple object and match it, like here. highlighted here. Or you can pass in a really bigger object, right, that's deeply nested, and you can tell your configuration, hey, if that deeply nested value matches 1, then return this file, and it wins. And it supports arrays as well. So this is how you would do an array configuration, and your object over here has a deeply nested value in an array. You can still match on it and return that file. Multi-part, a little trickier. Now you're dealing with potentially binary content. The mock server doesn't care what you upload. It uploads it into memory and it goes away. But it does match on the file names, which sometimes, as we're doing demos, we want something else to happen in case a certain file is uploaded. So we match on the file name as well, and Echo can handle that pretty nicely too. So great, now we have this mock server that's doing all these cool things, but then there's those couple of developers that still wants to load up their old server. So we gave them the ability to configure proxies into whatever service they're trying to get to. It can be a service on Google, it can be a service or server anywhere in the web. Typically it's done on another port on their machine. And depending on what browser you're in, you're going to get cross-site domain or cross-domain issues if you're doing AJAX calls. So this proxies all those requests to whatever server you want in the world with this configuration. It also supports command line arguments because we are like WebStorm developers and we have different configurations per, depending on what use case we're trying to do. So CLI, the Echo server can respond to CLI commands as well, or params, and it configures itself. Okay. Any questions there about the Echo? So great, we have a way to fake some data out. We have a common library that we're using. We have a style guide that we're using, and now we're going to get into how do we merge all these things together for the developer to build their web app. So this project was called the toolkit, and it's basically like a starter kit that you see online for a lot of different types of projects. It's based on a familiar stack with one addition. So it's using our UI kit, latest version normally. It's using the Availity Angular project. And you don't have to use those, I guess. It does have the Echo server built in. So if you download from GitHub, this is all there. It does use Gulp for some stuff, but we really leverage Webpack in this case to do a lot of the work that Gulp was doing. And then, of course, Jasmine and Karma to run our tests. So, this is a big change. We were using require.js before, but the world had moved on. Like, it wasn't the same, right? Suddenly AMD wasn't cool. Now Common.js was cool. So I'm like, all right, there was Webpack versus, I think, Browserify. Webpack resonated a little better to me in terms of managing web assets. Like, it's all chaotic, right? But Webpack kind of embraced that chaos. So we went with it, and it's worked out really, really nicely. This is kind of the project structure that you get if you download the toolkit. It's a starter kit, so we give you some entry points where you can start developing. This is how you would, we give you 2 files, one called index.js and then one called vendor.js. I'll show in a minute. And entry points in Webpack mean Webpack's going to introspect this file, read in everything that you're dependent on, and package it up for you. And typically the behavior is it packages up everything for you in one file. But having a 2 megabyte JavaScript file is abusive. So we split the vendor file and the app file into 2 different bundles, which is this. So we have a lot of dependencies here. You can see that for the Angular purists out there in the world, we do leverage jQuery. It's just because at the time we supported an older browser, but soon we won't. So this will clean up a little bit, but Webpack kind of makes sure that everything in this file isn't included in the other bundle, which is really nice. Another cool feature is as the bundles are created, we can actually have many different entry points, and that creates many different outputs or bundles. And we never have to update the index.html that's used to bootstrap our application as it loads in the server, because Webpack has these hooks built into it to where it does all that management for you. So as we add more bundles, it updates automatically for you. That's cool. Nope, actually never showed how Webpack actually runs. So this is our toolkit. You can see that it's kind of doing the whole gulp dance. It's also telling you, hey, developer, you're missing your default configuration. And it's perfectly fine. It's just a warning. But that allows you to configure your mock server, your proxies, different behaviors, like do you want a URL to open every time you get to the server loads or whatever. So it all looks familiar until you get down here where Webpack is actually doing a lot of the work. And it's analyzing not only your JavaScript files, but any references to images that may be in your templates, any references to images that are in your CSS or your less. We use less at Availity, not just CSS. It compiles into CSS, but it looks at all that stuff and determines what goes where. And really we got this because React was coming onto the scene, and then we kept seeing demos of Webpack being used in React, which hopefully one day we'll have a Availity React library soon. But that's where we got the idea from, and it's worked out really nice. It's require.js had its problems. That if someone had a wrong import where there was a misspelling, it would break the whole app, and it was hard to debug. And now the unfortunate side effect of using Webpack is you need a build process to build your apps. But where require.js did everything in the browser, but there's some performance gains for that at runtime. Let's see if I can load it. So we give you a sample app when you use the toolkit, and it kind of puts you in a mode to where you can just start developing and kind of learning the libraries that we've developed. You can see that we have validation already built in. You can click on stuff. And of course, this is all just examples. You wouldn't really, well, I guess you can use this in prod. But just an example of the stuff that's built in, and that's pretty much it. It just puts you, the developer, right in that zone to where you're always developing and not worrying about how this is all built together. It's really just a starter guide. Nope. All right. Testing's important, same kind of concept. This is built into all our apps that are producing JavaScript code. The only difference between this one and the other one, this one has a complexity report that kind of tells you, hey, your code is too crazy, slow it down. So if you score 100, you're going to be good. If you're at the low 10s, then it's time to refactor. But it's kind of that instant feedback that you get. So we released version .1 of this thing, and it was cool. It was like, this is different. I think it's better than require.js, but there was a couple of problems. I added more features to the 2.0 release, basically, and I couldn't upgrade the customers. It was a manual upgrade, and so the upgrade process was me going to someone's desk and upgrading them for them because I moved some files around, and kind of made it a little cooler, like how I thought it would be. And so it was a problem that we had to solve, and deploying was also an issue because now we went from an app that bundled all our apps to everything had its own Git URL. Everything was separate. So how do you ran all those things in together? So this is we're proof of concept. I'm about to release a new version of the toolkit where it auto upgrades itself. And the concept is simple. It's like we give you a project folder, and we don't touch anything in that project folder, and everything around you we can upgrade. And then we moved away some bootstrap files and workflow pieces that were inside your project, and we put them in another module for NPM. Allows you to upgrade using Semper. And deploying right now, we've not 100% solved, but the new version of the application has a little server that has a bootstrap code for deploying this project as a plugin, which is, this is all proof of concept now, but this is where we're going, hopefully. And I guess the idea was like, we loved Gulp because of the plugins and it was easy to create. We loved Webpack because it has plugins and then they're easy to create. Same thing with Metalsmith. So the funny thing is, like, we never built our website with plugins in mind, even though our backend system is this big Java process. it was all based on plugins. So we're moving towards, hopefully, that plugin architecture. So all these toolkit projects are combined as plugins, and you install them through NPM. So,
Ready for me?
yeah.
Hi, my name's Rob. And Rob and I work together, and in fact, Rob Ventrone, standing in the back, works as a developer on our team as well. Luckily, we have Lori and Jesus, and there's Jesus, Casey, and Mary. So you don't have to be named Rob to work on our team, but it does help. So here we have this great suite of tools, and we're using that internally at Availity. We're also working with external partners so that people can develop applications that run on our platform. And when you're working with tools like this, you need to be able to create projects. You need to be able to deploy those to the Availity platform. And so we talked about what are the best ways of doing that. We work with a fellow named Sean. And Sean is a young man, but he has an old soul. He runs Linux and BSD on his machines. He uses a window manager called Rat Poison. How many of you have heard of Rat Poison? How many of you have seen 3270 screens? Those are mainframe screens. So Rat Poison turns your Linux box into a mainframe screen, mainframe terminal. You have only command line. Now command line, however, has a great place in creating tools that do things very quick and do things that you need to be able to send parameters to and so forth. And Sean is our configuration manager. And somebody once was having problems with Git, and they were using SourceTree. How many of you are familiar with SourceTree? It's a GUI application for Git. And his response when they said, you know, I'm having this problem with SourceTree, he said, never send a GUI to do a command line's job. And as we talked about, how do we initialize these projects? How do we deploy those to the Availity platform? This really was a command line job. And so we talked about creating an application. How many of you are familiar with Heroku? Heroku is a hosting platform so that you can write applications, whether they be Ruby on Rails applications, Node.js applications. They support a wide array of technologies, but you interface with their platform not just through their web GUI, but you also have a command line. You can create a project, you can deploy it. And so we sort of dissected the Heroku command line, trying to understand how they were doing things and what things would developers be familiar with. So to be able to create projects, initialize projects, and so forth. We needed to create a platform, we needed to create a CLI that was cross-platform. Several of us run Macs. Some people on our team run Windows machines. We have partners that are running Windows, partners that are running Macs, some even running Linux. So we talked about what technology should we use to build this tool. We started with Ruby. Why don't we build it in Ruby? That's what the Heroku CLI uses. We have some Ruby expertise on our team. We've written Ruby code. It's great for making command line applications. However, we would be introducing a dependency. Our partners would have to install a Ruby machine on their, install a Ruby distribution on their machines. And some of our partners are big corporations with laptops that are handed to them by the IT department that have the software on them that they're allowed to run, and they wouldn't be able to install a Ruby virtual machine. We also talked about Java. In Jacksonville, we're chiefly a Java shop. We have a lot of Java expertise. You can write command line applications in Java. However, we ran into the same sort of issues that our customers would have to have a Java virtual machine on their computers. There was a time that that was a given. Now you're no longer assured to have a Java virtual machine on your computer. So we said no Java. We also talked about C, writing it. No, we didn't. We didn't talk about that. So we said, why don't we write it in Node? we're already requiring for people to use our stack that they have Node installed. And you can write terrific cross-platform tools in Node. We have no additional dependencies because they're already going to have Node on their machines. There are several libraries available for Node for a wide array of things, so we have ample library support. And it would be easy to distribute CLI written in Node. We put it on NPM, people do an NPM install, and they've got our Availity CLI. And so that's what we did. And so here's an example usage of how you use the Availity CLI. You want to create a project, you say Availity init, and then you name your project. It then steps you through several questions, and so you can see right there, that's the questions that they ask. And then when you're done answering your questions, it creates your project, puts it in the Availity toolkit, all the other libraries, the Echo server, and everything you need to build these tools to run on the Availity platform. So you CD into the directory, you fire up your editor, whether that's Sublime or Vim or Emacs or whatever. Sean, by the way, the old soul uses Emacs, but I think he's the only one that does. And you write your code. You use this great array of tools that Rob McGinnis talked about. Now when you're done and you want to create and deploy the application onto the Availity platform, you run Availity create. We actually have a GitLab server. Are any of you familiar with GitLab? GitLab is an open source tool similar to GitHub. They have a hosted platform, but they also have an open source version that you can host on your own hardware. And so when you run Availity create, it will actually create the project on our GitLab server. It will upload any keys that your public keys so that you can push your code. We don't take over your source control. We just use Git as a deployment platform. So you add your files, you commit, you push we create a remote called Availity. You push to Availity master, and that's how you deploy your projects to the Availity environment. Questions so far? Well, we ran into some issues. One of the things we found was that the libraries that we were using to build our Node app, some of them required that when somebody did an npm install, that they be compiled on the target machines. Well, that seems something pretty trivial, right? Because, I mean, we're all developers, right? We should have build tools on our machines. We should be able to build libraries. However, as you'll recall, I mentioned earlier, we are working with some enterprises where they received the laptop from the IT department, and they couldn't install things like whether it was Xcode, whether it was Visual Studio, whether it was GNOME Keyring. People couldn't just install what they needed to run these tools.
Were these Node.js specific dependencies?
Some of them were, yes. And so with some of the libraries that we were trying to use. And so we had to work around those as we worked with our partners. Now another thing, Rob here calls me a grumpy old man, and I guess I am significantly older than he is. But as we were going through writing this CLI, we fell into callback hell or promise hell. And it's one of these things that when you talk about it, it seems like, well, with promises you just do this, then this, then this, then this. And from a theoretical standpoint, it seemed like it should be simple. However, as we're writing a command line tool, which by its nature, we needed things to happen sequentially. And how many of you are familiar with promises and callbacks and so forth? With Node, it is by nature asynchronous. It runs some code and it will call back. It's not really multi-threaded, but it looks like it's multi-threaded, so that things don't happen in order. And so you have to work around that. You use promises, and that works great for a server environment. That works great for a browser environment. It works great for network activities where you don't want to hang up your server waiting for something to complete. However, on a command line where you want to check if a directory exists, you want to wait until the return comes to you that yes, the directory exists before you proceed with the next function call. And so we spent a lot of time cursing promises in Node, and I apologize for that, but it was frustrating. We were able to complete the tool. We have the tool out on GitHub, and it does its job. However, as we talked about moving forward, what things we need to add to it, we realized we can write this tool in Node, continue to write this tool in Node, but in the immortal words of Ian Malcolm, just because something can be done doesn't mean it should be done. So we started talking about what are some other technologies that we could use to solve the problems that we were facing. We were spending really too much time in development, too much time in figuring out how to test the code through automated testing because of the promises. Now, I don't know if any of you were able to see James Nugent's talk earlier today on Go, or how many of you are familiar with Go? A few of you, excellent. Go is an interesting tool. It is something that at least merits you looking at. It is cross-platform. It runs on, the code you write runs on Windows, it runs on Mac OS X, it runs on Linux, runs on a few other platforms. It's a compiled language. It runs very fast. One of the things that we noticed was that because it doesn't have to load a JavaScript engine on startup, for a command line tool, it starts up much faster than our Node version of the tool. It statically links all its dependencies at compile time. So when we compile a binary, and we can compile one for Mac, we can compile one for Windows, we can compile one for Linux, we distribute that, we know that the user has everything they need to run the tool. It's all there in the binary. And the programming model is a better match for command line tools. There are tools in Go for writing concurrent multi-threaded code. However, you do that on purpose instead of it being the default and having to work around it. So here's an example. We wrote, this is our method to unzip a file in JavaScript, and we have some feedback in there about the completion percentage and so forth, and we're doing things like these callbacks, and we're piping it, and using a promise, and then this was our Go version. Because this waits until it finishes before it goes to the next line, this waits until it finishes before it returns. That was a much better match for what we were trying to accomplish. Now, in Rob's talk, Rob McGinnis's talk, he had a whole lot of screenshots of Sublime. And so this really is just a gratuitous screenshot of Vim, because I'm a grumpy old man. But this is also our rewrite in Go of the command line tool, which is a work in progress. It is available on our GitHub. We are not as far along, and it's not without its issues as well. One of the things we're finding is there are fewer libraries. It's not as mature as Node. We're having to write a few of the libraries ourselves. We're having to fit this in. Nights and weekends kind of work to get this moved forward. But we think that this will be a better programming model for our command line tools. Questions? So this is our contact information. We would love for you to go out and use these tools, fork them, submit pull requests, give us feedback. We really are trying to advance Availity as a platform for other applications to run on and to use these tools and spin up applications much quicker than starting from scratch. Thank you for coming. And now we'll give it to Jack.
Sure.